A job interview begins, and the interviewer asks a question that many engineers are now hearing everywhere. The interviewer asks, "What is agentic AI?" The candidate pauses because this concept sounds simple but hides a powerful idea. Then most people think AI only answers questions or generates text. But AI that takes action behaves very differently from traditional AI tools. Instead of waiting for commands, it can decide what steps to take to achieve a goal. Now, traditional AI tools respond only when someone asks them something. But the shift from chatbot to autonomous agent means AI can start doing tasks on its own. This change is why engineers and companies are so excited about agentic systems. To understand agentic AI, we must look at how it behaves internally. Agentic systems follow the pattern goal, plan, action. This means the AI first understands the objective and then decides how to complete it. Of course, modern software systems are becoming too complex for humans to manage every step manually. That is why companies care about agents is becoming a common interview topic. Autonomous systems can manage tasks continuously without waiting for human instructions. Now, before understanding agentic AI, we must first understand the idea of an agent. An AI agent is a system that observes its environment and decides what actions to take. It behaves like a digital worker trying to achieve a goal. Then agents behave through a repeating decision loop. This loop is often explained as observe, decide, act. The system looks at information, chooses a step, and then performs the action. Of course, an AI agent cannot work effectively without access to tools. The idea of tools for AI agents means giving the system abilities like searching, coding, or calling APIs. These tools allow the agent to interact with real systems. Now, agents also need memory to remember what has already happened. The concept of memory for agents allows systems to track context across many steps. Without memory, the agent would forget its progress and repeat work. Next, complex goals require breaking work into smaller steps. Agent systems perform planning task breakdown before executing tasks. This allows the AI to create structured workflows automatically. Then many modern agents are powered by large language models. In these systems, LLM, as the brain, decides reasoning and next actions. The model interprets goals and determines the next logical step. So agentic AI works through repeated reasoning cycles. This process is often called the agent thinking loop. Each iteration allows the system to evaluate progress and choose the next action. Now, one popular architecture is called reasoning and acting. The concept, reason and act, allows an AI to alternate between thinking and executing steps. This approach improves reliability and decision-making. Then the real power of agents appears when they can interact with external systems. An agent with tools can search the web, query databases, or run code. This transforms AI from a passive assistant into an active system. Of course, agentic AI enables automation across multiple steps. The concept of autonomous workflow means tasks can complete without constant human supervision. This is why businesses see huge potential in agents. Now, many real problems require multiple steps to solve. Agentic systems excel at multi-step problem solving. They can research information, analyze results, and then generate a final output. Then modern software systems communicate through APIs. Agentic systems work by agents using APIs to access real services. This allows the AI to interact with databases, applications, and cloud systems. Now agents can also evaluate their own outputs. This idea of agent self-correction means the system can detect mistakes and retry. This loop improves reliability over time. Sometimes a single agent is not enough. Systems called multi-agent systems use multiple agents working together. Each agent specializes in a different task. Then different agents can have different responsibilities. These specialized agents may handle research, coding, or validation tasks. This division improves efficiency. Now, when multiple agents work together, coordination becomes important. The system must manage agent coordination between tasks. This ensures the workflow progresses smoothly. Then agentic systems rely heavily on evaluation cycles. These cycles form feedback loops that guide the next action. Feedback helps the system improve results. Of course, not all agents operate at the same level of independence. Different systems implement autonomy levels depending on risk and complexity. Some require human approval, while others run fully automated. Now, agentic AI is quickly becoming part of modern applications. We now see agents in software handling tasks like monitoring systems or generating reports. These agents reduce manual work for engineers. Then a full agentic architecture includes many components working together. The agent ecosystem usually includes models, tools, memory, and orchestration layers. Understanding this structure is important for engineers building AI systems. Now companies are already experimenting with autonomous agents. Examples of real-world agent use include automated research assistants and coding copilots. These systems help engineers move faster. Then, agentic AI can automate repetitive tasks. The concept of AI automating work means systems can perform operations continuously. This dramatically increases productivity. Now, modern AI engineers are building agent frameworks. This shift means engineers build agents instead of just training models. The focus moves towards system design and orchestration. Because of its importance, this topic often appears in technical interviews. Understanding agentic AI interview question concepts can give candidates an advantage. Interviewers want to know if you understand the architecture behind agents. Then a good interview answer should start simple. Begin by explaining how to explain it using the goal, plan, action concept. Then describe tools, memory, and reasoning loops. Sometimes interviewers ask for a simple explanation. You can summarize agentic AI in one line as AI systems that plan and execute tasks autonomously. This captures the core idea clearly. Now, a strong explanation also mentions the architecture. The key components include the LLM brain, tools, memory, and planning logic. These pieces form the foundation of agent systems. Then, interviewers often appreciate system-level understanding. The agentic AI architecture connects reasoning loops with tools and memory. This allows autonomous task execution. Now, agentic AI represents the next evolution of intelligent systems. Understanding why agentic AI matters helps engineers design future software. It shifts AI from answering questions to completing work. Finally, the candidate finishes the explanation with confidence. Understanding clarity builds careers is why learning these concepts matters. Deep clarity about modern AI systems helps engineers stand out in interviews.